Okay, welcome back. This is chapter 2 in the PSNA book. Okay, so page 23. Let's continue. So this whole thing is about the small batch principle. All right, so I alluded to in the previous chapter that whole concept of small batch versus large batch. There's a good example. It talks about a carpenter who has a wobbly blade in a table saw. Okay? So he knows that there's some variation that happens whenever he cuts the wood. So continuous improvement would mean I cut 1 or 2 boards, I verify that they're the right length because the blade hasn't wobbled, and then I tweak it and then continue cutting. That's the continuous integration technique, continuous improvement rather. This large batch principle would be I cut them all. I cut 100 boards. And then afterwards I inspect them and go, oh man, these are too short and these are too long, and I throw away the defects. Okay? So let's talk about this. So one technique is you might think it's slower because you cut like 2 boards, stop and check, tighten the saw blade. Cut 2 more, stop, check, tighten the blade, and you just keep going, right? And you might think, well, that's too much, it's not assembly line, like the Ford Motor Company, back in the 30s, I want assembly line production, but the problem with assembly line when you have a wobbly saw is that you're producing them, but they're not going to be the high quality. So don't get duped in the idea of I'll do all that stuff all at once and get all that out of my way and off my plate. That's a dumb idea. Okay. So the whole concept of latency. So let's say that you're out on a construction job and you're cutting, 2x4s for interior walls, and you need 100 of them. So you just start cutting. You don't actually deliver them until after you're done, all 100. Okay, so everyone else is standing around waiting for you. The small batch was you do 3 or 4, and you deliver 3 and 4, and then you do 3 or 4, and you deliver 3 or 4 of these. So there's the latency, which means they get the product. They don't get the whole thing all at once, but they at least start getting something faster. So waiting until the end to deliver the product, now you can kind of already tell this is an excellent analogy to a software product. I can give you nothing until all 10 features are ready to go. Or I can give you 2 features and have you look at it, and then 2 more and have you look at it. See? Okay, very good analogy. Anyway, that basically talks about the small batch and large batch. If you have variation, small batch is better. It maybe doesn't look like it from the onset. And then clearly for latency, you get to see the product happen. And for enjoyment purposes, don't you have a sense of fulfillment and personal satisfaction when you can say, hey, wow, look at what I just did? Well, if you have to wait 6 months to get your gratification, that's kind of demoralizing. Wouldn't it be kind of cool if you could have like instant gratification like once every couple of weeks? I'm just saying. All right. So they have this example they talk about throughout the entire chapter called Hell Month. And so they did a new software release in this company every 6 months. And the deployment and the testing was all done by hand. They didn't have any automation whatsoever. And again, how come you guys don't automate that? Well, we don't have the time. We're too busy mopping the floor to fix the leak. Exact same thing. So there was always high priority bugs, and after that, hot patches. And so everyone hated Hell Month because the month that we submit these things to be tested, and basically no one took leave during that period of time. All hands on deck, and it was horrible. Everyone was grumpy. They went to and said, okay, what can we do to fix this? Because this is just driving us insane. And they were kind of sort of management was expecting them to say, well, let's don't release every, 6 months. Let's release every 12 months. And that way, we can go longer period of time without having to go through hell. And that's not what the developers said. What the developers said, by the way, they probably had a little bit of help. But the developer said, no, let's increase the frequency of the deployments. And they went, what? You mean you want Hell Month to happen more often? And it's like, yeah. Okay, so you might think, how the heck is that going to make things better? To have this horrible release cycle happen, not every 6 months, but every month? Oh, geez, that would make things miserable. Well, you need to switch to that small batch thinking. That's the whole point here. What happened is the developers now were only making small changes in 1 or 2 features. Well, those things are easy. Making a small change and 1 or 2 features, it makes it so much easier for the developers, so much easier for the testers, so much easier for deployment. Okay, and it gave them enough time on their hands that they could actually start doing some automation of the task. The automated, you remember the continuous integration and continuous delivery kind of a thing? Yeah, that stuff. So it made it more reliable because it had enough time to actually do automation. And smaller steps basically means smaller pain. So hell month went away when they did it from 6 months to 1 month cycle. Okay, so there's a bullet list on page 25 and 26. You'll see some of the highlights there. So the features arrive faster, that latency issue we talked about. No, I don't get them all, okay, but I get 1 or 2 features and I get them faster. Hell month is now gone because we're doing it faster. The team focuses on the higher priority things because they're not running around chasing their tails anymore. It makes it faster to fix bugs because we didn't make that many changes. I mean, it's sort of like if you're diagnosing your car and you go, well, let me change this, this, and this, and then it worked. And you go, I wonder which one of those 3 things was the fix. You don't know. But if you only made 1 thing and checked to see if it fixed, nope. Just do the second one. Ooh, it did fix it. That's the concept here, right? It's faster to fix the bugs because you didn't make that many changes. Okay, instant gratification. That's good. To keep the morale up for your developers, don't make them wait 6 months before they can go, wow, I'm really proud of this. Look at this cool stuff I did. Yeah, see? You have to wait. That's not good. And then, of course, less stress because, you're not running around like a bunch of maniacs, running around like heads with their chickens cut off. I love that phrase. It's a cool twist of the thing. And then, of course, there's some business-related improvements, right? First of all, this is going to help you with your competition because you're going to be producing products faster. You're going to have fewer, missed opportunities that come by because you got the time. And then the whole concept of this rapid continuous integration, continuous delivery, that whole culture actually helps a great deal in your productivity. Okay, kind of sort of talking, again, this is all still small batch, large batch. On page 26, they talk about emergency failovers. So Stack Overflow, that's a website I go to. They have a website in New York, and they have a replication of that in Colorado, okay? The problem is configuring a failover was very complex. If something went wrong, they had an awful lot of work to do. For example, it took them about 10 hours to go through and get everything going because they thought they had everything replicated across, and like maybe they didn't have the accounts replicated, and so when they switched them over, nothing actually worked. And so, yeah, that's a big batch problem because you're making this. Let's say you picked a day. You say we're gonna test the failover system, and so you try it, and then you spend 10 hours trying to get this thing to work. It's like, oh man, because you've never really done it before. There's an awful lot of things that go on. So it's one of those things where you do, learn, and fix, right? You have to do it. You have to have an after-action report to say what worked and what didn't, and you have to fix the thing. Well, that kind of implies repetition, right? You don't just do, learn, fix one time. You do, learn, fix multiple times, over and over and over. So scheduling a failover exercise, yeah, that's what we're talking about. Okay, so you could run a drill after you make some significant changes to your system. Let's say, for example, I don't know, you added a new database table and a new account that uses something. So you made a significant architectural change. Now's the time to schedule a failover to make sure that those changes that you made actually work. Okay? Good. So every plan has to be exercised. So you have a failover plan, you're going to have to do it. Remember the do, learn, and fix? So the first time they did it, it took 10 hours to do. The second time they did it, it took 5 hours. The third time, it took 2 hours. The fourth time, it took 1 hour. Small batch. You're doing it more often, and you're basically fixing it. So you remember the whole 5 nines availability thing? Maybe you've not heard that term, but basically it's 99.999% uptime. Okay, so if you have 5 nines, you probably need to do a forced downtime, and that sounds like counterproductive. Like, wait a minute, you just told me that we're good for 99.999. So that's the time that you should force a failover exercise, because you want that high attainment. Okay, not the other way around. It's like, oh, I already have 5 nines, I'm not going to exercise. No, you're going to need to exercise. Okay, so there's a bullet list on page 28 and 29. So few surprises, right? When you start making these changes, again, small batch. I make a change to the database and add an account, and I want to make sure those tiny little changes got replicated. Reduce risk. Because you're doing this exercise more often, and after you've made some configuration changes, you now have an opportunity to basically say, okay, I can achieve the 5 nines now, because I have some degree of confidence that the system is going to be able to work. Okay, faster bug fixes if something comes up. Less stress when you're doing a bug fix. It kind of makes sense. Better cross-training. There's a really cool example coming up with Google. Talks about training the developers to make sure that if you write an application where you assume a particular resource is available and then it's not, how is your application going to respond? Is it going to crash? Is it going to lock up? Something. Better documentation. So every time you do one of these do, learn, fix cycles, you write down what worked, what didn't. I remember an exercise at Fort Hood 10 million years ago where we did a disaster drill of some sort, and we discovered that the military police radios couldn't talk to the fire department radios. Like, oh, I'm sorry, I thought we were all using the same frequency. No, something went wrong. And then, of course, you have happier staff and better morale, which is always a good thing. So the Google example is an excellent one. You probably need to read that little shaded area. They talked about how they had one particular device, time server, that the developers basically said, well, this thing's always going to be available, okay? And then one day it wasn't, and things started really, really going wrong. So they said, I know how to fix this. We're going to deliberately take this critical thing down. Yes, they actually schedule deliberately denying a service to make sure that all the rest of the systems can respond correctly. That's a crazy story. But basically, they actually schedule 5-minute downtime every so often just to prove that the developers have written resilient enough code that when this resource that they assume is going to be available all the time isn't, what happens next? Okay. On page 29, they talk about launch early and often. Sometimes they call this fail early and often. I learn an awful lot by my mistakes. So, whether something is successful, an experiment is successful or failure, you always learn something regardless, right? Okay, good. So here's the example they talked about is they're building a server monitoring system, some sort of a system that would, look at all the servers and give some sort of like some sort of a report or maybe something that alerts you when something is going wrong. Okay, so 2 choices. I'm building this thing. Should I wait until it's completely done before I deploy it? That's the large batch thinking. Or should I just do 1 or 2 features and let you look at it and let you get some feedback? Okay, you already know which way we're going, right? Okay, we're coming up on the 15-minute mark. You guys know how this works.